Okay, so we're going to continue the review now. We're going to look at number 52, which is identify each line segment that intersects each circle. So the first thing we're going to look at is we're going to look at radii. Now remember, radii is plural for radius. So we're looking for a radius. Remember, a radius is a segment whose endpoints are the center of the circle and a point on the circle. So we have PU, segment PU is a radius. Segment PQ is a radius, and segment PR is a radius. So those are your three radii that you have. Okay, so now let's look at the diameter. The diameter is the segment that passes through the center and the endpoints are on the circle. Well, we only have one, RQ. Segment RQ is the only diameter that we have. Okay, so now let's look at the tangent. Remember, a tangent intersects the circle at one point. So we only have one of those, and that's this line right here, line UV. Okay, line UV, that's our tangent. And U is the point of tangency. If you remember that, that's what we call it, the point of tangency. Okay. Then we have the secant. Remember, secant intersects the circle at 2 points. And so here's our secant right here, line ST. Now, notice that I called it line ST. That's because the symbols matter. How you label it matters. For example, the next one asks for chords, right? Well, segment ST is a chord. Line ST is a secant. And what else is a chord? Well, the longest chord in a circle is always the diameter. So the diameter is always the longest chord in a circle. So those are all your spots right there. Okay? All right, so that's 52. Now let's turn the page and we'll look over here at 53. Let me get this in here where I can, there we go. All right, using circle O below, circle with the center of O, find the measures of the following. It's not drawn to scale, which means not everything's going to look as it's measured, okay? I'm going to use this calculator up here to kind of hold this in place. All right, so find the measures of the following. The figure's not drawn to scale. Notice there are both arcs and angles listed. Be careful that you notice the difference. Remember, an angle is an angle, like we know a traditional angle. An arc is an arc, okay? What is the measure of angle BOC? BOC is a central angle, okay? That's a central angle. So it is the same as the arc. So it is going to be the same as arc BC, which is 141 degrees. So all of the central angles are the same. Now let me see if there are any more. BOD, DOE, AOE. Okay, so let's look at another central angle. B, AOE. That goes from A to O to E. That's this angle. Well, that is going to be the same as this arc right here. Well, we don't have a measurement for that arc yet, so we can come back to that and figure it out in a little bit. I'm going to show you how to do that with the figure. I think there's a number that's missing there, and we might have to make something up to get it to work. So let's look at some of the things that we can get. Okay, you can tell by looking at the picture that AD is a diameter. Does everybody agree on that? Good, I'm glad you can, because you can't argue with me. Alright, so AD is a diameter. That means that this is a semicircle, or a semicircle, however you want to say it. What do semicircles add up to? 180, right? This central angle right here is 32, which means the arc is 32. That's 141. So to find arc AB, it's going to be 32 plus 141 subtracted from 180. So turn the calculator on. We have this one, which is 32. We have that one, which is 141. So that's 173. And I'm going to take 180 and subtract that 173. So this arc is 7. So arc AB is 7 degrees. So we can come down here and say arc AB is 7 degrees. Okay? Now, because I know that's a diameter, this is also a semicircle as well, correct? Correct. Again, you can't argue with me because I rule. And you can't yell at me through a camera. And I really need to get back on this. So I have 82 plus this arc, which is 180. So I'm going to take 180 minus that 82 degrees, which means this one is 98. So arc AE or EA right here is 98. And I'm sorry the symbols didn't show up. These are arcs. These are arcs, arc, arc. Okay. All right, so now let's go back to AOE. AOE is this guy. Well, it's a central angle, AOE, so it's 98. It's the same as its arc. How about BOE? BOE goes from here to here. So BOE is the 98 plus the 7. Y'all see that? BOE opens up to the 98 plus the 7, which is 105. Okay. Sorry, I'm trying to hold this still. Hopefully you can see this. It's a little crooked. I'm a little OCD. There we go. And so let's look at some of these other arcs. Arc CE. Well, CE goes from C to E. What do we call arcs with 2 letters? Minor arcs. Remember, minor arcs are less than 180. Major arcs are larger than 180, and we use 3 letters. And semicircles or semicircles are 180, and we use 3 letters. So let's look at CE. CE goes from C to E, so 32 plus 82. And I'll go ahead and write that here so you can see it. 32 plus 82, which is 110 and 114. I believe that's 114. Okay. Because that's from here to there. Okay, that's CE. So let's check out another arc. This arc here, DC. Well, what is DC? We already know it's 32. You saw for that earlier. Okay. And let's look at the last one. Let's look at AED. That means you start at A, go through E, and finish at D. Well, what is AED? If AD is a diameter, that's a semicircle, so that's 180 degrees. So let's check out these other angles now too. COE. So I'm going to start at C, go to O, and go to E. So COE is this angle right here that opens up to CE. And we've already established that CE is 114. And again, the reason these arcs are the same is because they're central angles. And then BOD. That goes from B, O to D. So that's this arc. B to D. Well, that's 32 plus 141, which is 173. So you've just found all of your arcs for that particular circle. Okay. 54 we did in class. When you find the area of a sector, you're finding a percentage of the area of the circle. So the area of this circle, remember area is pi r squared. The radius is 2. So the area of this circle is pi times 2 squared, which is 4 pi. And if you want to write that out, we can do 4 times second pi. And that's about 12.6. I'm going to round it just so you can understand it a little bit better. So that's 12.6. So the whole circle is 12.6, right? I don't want the whole circle. I just want the piece of it. I just want that piece that's shaded. Well, I need to find the percentage. What part of the circle is taken up here? Well, 47 degrees. How many total degrees are there in a circle? 360. So I'm going to multiply that 47 out of 360 times my 12.6 or my 4 pi. And that'll tell me what exactly I have. So if I take 47 divided by 360, that tells me that's about 13%. If you remember how to do percentages, that's about 13%. So we're looking at about 13% of the circle. So 13% of 12.6. So I'm going to multiply that 13% times 12.6 and it's 1.645 feet squared. Okay, so that is the shaded region. So it's just a percentage. Now when you do the arc length on 55, you're doing the same exact thing, except instead of using area, now we're talking about arc length, we're talking about circumference. So the circumference of this circle is 2 times pi times the radius, which is 1.5 meters. So that's equal to 3 pi meters. And again, if you want to multiply this out, and normally I would tell you not to multiply this out because this is a lot more accurate than rounding. But I want y'all to understand what a partition or sorry, a piece is and how to get a portion and a percentage. So this is going to be approximately 9.42 meters. And that's not meters squared because we're not doing area. Well, we want to know AB. Well, how much of the circumference does AB take up? 160. So AB takes up 160, and I'll use a different color so we don't get confused. AB takes up 160 out of the 360. If I do 160 divided by 360, that gives me roughly 44%. 44% if you can see it, okay? That's basically what that represents. And I'm going to multiply that by 9.42. I'm going to get 44.4% of 9.42. And so that's going to be 4.19 meters. And that's how you do sector area and arc length.